design, and basic operation. Throughout this program, important safety information will be highlighted. Safety first means stop and think safety before you undertake the next welding procedure. It's also important to always develop your welding skills under the watchful eye of an experienced teacher. There is no substitute for hands-on training. To prepare for shielded metal arc welding, a student should have the correct protective clothing. Flame-resistant pants and shirt are important, as well as a cap and heavy leather gauntlet-type gloves. Electric arc welding creates harmful ultraviolet and infrared rays. All bare skin should be covered when welding with an electric arc outfit. In addition, a welding helmet is required. A number 10 to number 14 filter lens is recommended. The helmet cover plate shields the lens and the welder from sparks and hot metal. Safety glasses protect the welder when chipping hot slag or metal. Toxic gases are also created during arc welding. Be sure there is adequate ventilation. An exhaust pickup system protects the welder from fumes by venting gases and smoke from the area. In shielded metal arc welding, the base metal and weld are shielded from the environment by a shielding gas. This gas is supplied by the flux covering on the electrode, which melts as it is used. The melting electrode also supplies filler metal to build up the weld. Arc welding machines are of two types: alternating current or direct current. AC machines are commonly used in industry, on the farm, and in the home shop. Direct current machines are more versatile and are often used in manufacturing. The current from the welding machine is passed through electrical cables called electrode leads. The workpiece lead connects the machine to the work. It is also the ground for the system. The electrode lead ends in the electrode holder. The holder is an insulated clamping device which holds the electrode and protects the welder from shock as he works. Safety first. Electrode leads should never cross traffic areas or be left where people may come in contact with them. Always keep leads out of the way of others when welding. Electrodes deposit filler metal in the weld pool. As we saw, the flux or outer coating on the electrode creates the shielding gas that protects the weld from impurities. Electrodes are sized according to the diameter of the uncoated wire. The American Welding Society has developed a numbering system which allows you to identify the proper electrode for the job. The letters AWS are followed by a suffix indicating the type and usage for each electrode. Consult the manufacturer's chart if you are not sure how to choose the correct electrode for the job. Setting up to weld with a shielded metal arc welding outfit should be done methodically and in a given order. First, visually inspect the machine with the current in the off position. All leads should be tight, with no bare wire showing. Check the workpiece lead for damage and make sure it is tightly connected to the work table or workpiece. Check the entire length of the electrode lead for damage and make sure it is tightly connected to the electrode holder. The electrode holder must not be in contact with the table or work when the machine is turned on. Damage to the machine may result. The welding area should be clean and well ventilated. It should provide protection for people outside the area from metal, sparks, and the arc light. There should never be combustible material in or near the welding area. Safety first. Never operate a shielded metal arc welding outfit near standing water. A severe electrocution hazard exists whenever water is present. Coarse and fine amperage adjustments should be made on the welding machine before the machine is turned on. The type and thickness of the work, the electrode size, the input current, and the length of the leads determine the correct output settings. Never set a machine without supervision until you are familiar with determining the correct settings. It's important to select the correct electrode for the type of base metal being used. Metal thickness, groove design, joint alignment, and skill of the welder should all be taken into consideration. Once you have made the correct adjustment, power can be supplied to the machine. Make sure the electrode lead is not in contact with the work or any other object. If you have followed the previous steps carefully, you are ready to start an arc. First, grip the electrode holder in a comfortable position. The electrode lead can be draped over the welder's shoulder for comfort. A welder should always alert others in the general vicinity where he or she is striking an arc. Watch your eyes is a good warning whenever you're starting to weld. Safety first. Never weld on a closed container that has not been properly prepared and vented. There is always a risk of explosion with closed containers which may have contained oil, gasoline, or other flammable materials. To start an arc, the electrode can be scratched on the base metal with a glancing motion, or it can be tapped straight up and down. Both methods create momentary contact between the work and the electrode so that current begins to flow. Pull the electrode back to the correct arc length to maintain the arc. It is also important to know how to shut down the outfit properly. Never leave an arc welding machine in the power on position if unattended. Step away from the work area to turn the machine off. Store leads and the electrode holder carefully when not in use. Laying a bead with an arc outfit is similar to the procedure used with oxyfuel. Once the arc is struck, a weld pool begins to form. Filler metal from the electrode melts and joins the weld pool. By moving the electrode laterally, a bead is formed. The arc length must be kept uniform to create a good bead. The electrode can be held vertically or at a slight angle, about 20 degrees from perpendicular. There are two primary kinds of beads. A stringer bead is made along a straight line with a steady straight motion. A stringer bead should be 2 to 3 times the width of the electrode. A weaving bead is made when the electrode is moved from side to side. A weaving bead can be 5 to 6 times as wide as the diameter of the electrode. When the bead is completed, it must be cleaned and examined. This is called reading the bead. A chipping hammer and wire brush are used to remove the excess metal, slag, and splatter from the work. Safety first. When cleaning a bead, always wear safety glasses. Never chip hot slag or other metal without proper eye protection. The size and formation of the bead indicates the strength and quality of the weld. A well-made bead has ripples with a clear bullet shape. The bead should be about 1/8 as high as it is wide. Defects occur in the welding process when good technique is not used. Undercutting happens when the electrode angle and rate of speed are not correct. Establish a firm grip and move the electrode methodically to rectify this problem. An arc may fail due to poor welding technique. If so, it must be restarted. A crater will form whenever a bead is stopped for any reason. To complete a solid bead, the arc should be restarted approximately 1/2 inch to 1 inch ahead of the crater. As the weld pool begins to form, move the electrode backwards until the new pool connects with the old. Then continue with a steady forward motion. The weld should be solid and unbroken. You may need to adjust the amperage of the machine. Safety first. Never adjust the polarity or current of an arc welding machine while it is in use. Always shut it off. Direct current welding holds another problem for the welder. The arc created with a direct current machine is influenced by the extreme magnetic field made by the current passing through the electrode and the base metal. This deflection of the arc from a straight path is called arc blow. It is most evident at the end of a joint or corner. The fluctuating magnetic field tends to draw the filler metal out of the joint. Repositioning the ground lead and using a shorter arc sometimes helps to solve this problem. Some work requires multiple passes to build up a strong weld. In this case, an initial bead called the root pass is run first. This is the most important pass as it must penetrate the metal completely. Additional passes will build up the joint for strength. They should be run evenly and overlap each other. Not all welding is done in the flat or horizontal position. Vertical welds require special skill. A downhill weld begins at the top of a joint and proceeds downward. An uphill weld moves in the opposite direction. It takes some experience to run a solid bead in the vertical position. This is an example of a good multiple pass weld made with a shielded metal arc outfit. the quality of the welds you are able to accomplish will depend on your ability and your understanding of the methods and practices of modern welding. With that ability, many career opportunities await you in manufacturing, industry, and construction, where modern welding skills are essential.